The Metadata War, SOSUS, hydrophones, and the Ghost Map. To outsiders, SOSUS sounded like science fiction, miles of hydrophones on the seafloor. Inside the program, it was physics with a pencil. You didn't hear a submarine. You stacked hints, a low-frequency impulse here, a line of bearing there, faint energy moving the way steel moves through deep water. The March 8 bang wasn't poetry. It was a data point that let analysts draw a box and say, look here. Start with the ears. The fixed arrays, long lines of hydrophones anchored to basalt and cabled ashore, fed NAVFACs in places like a DAC. Operators watched LOFAR waterfalls for behavior that refused to be weather. The Air Force's AFTAC stations added their own triangulation from great circle paths that bent around temperature layers. Lines crossed. The box tightened. It wasn't magic. It was metadata, time, frequency, bearing. What nobody wrote in a memo was the discipline. SOSUS trained you to distrust drama. Storms smear low bands. Shipping throws harmonics that pretend to be important. The job was subtraction. Strip out wind, remove merchant screws, ask what remains stubborn. That's how the good-sized bang rose out of ocean hiss. 4 sites heard it. Different bearings, same night. Draw the geometry and you get the grade. Then the map expanded. The US didn't guess at deep currents. It measured them. Oceanographers handed over sound velocity profiles, how temperature and pressure bend waves, which let analysts predict how that impulse would propagate. The model said the source lived near 40 north, on the 180th meridian, in water around 16,500 feet deep. The metadata became geography. Geography became a task order for Halibut. Meanwhile, something else was happening in the noise: pattern recognition. Once Halibut's photos confirmed the wreck inside the SOSUS box, the system learned what success felt like. Arrays that had looked like static started to look like a history book. Analysts pulled old reels, reran filters, and found faint clues they hadn't known to trust. Not more bangs, shadows that matched the debris field's implied path. The ghost drew itself darker the longer you stared. And here's the quiet twist. SOSUS wasn't built to find graph. It was built to hear patrols. That habit mattered. When you tune your brain to track slow steel moving against low bands, a sudden impulse stands out. The metadata war wasn't about a single event. It was about teaching people to see consistency in a sea of exceptions. By the time K-129's box was drawn, crews at a DAC could name storms by their signature and tell a freighter from an ice breakup by the way the waterfall breathed. Onshore, the ghost map turned bureaucratic. The acoustic fix drove requirements, a region to cover, dwell times to meet, a sensor package Halibut could drag without snagging the world. Navy ocean engineers sketched tow patterns like farmers planning furrows, offset lines to cover the box efficiently, with overlaps to catch what luck would miss. It looked boring on a board. It wasn't 3 miles down where silt blooms on a camera's glass. What nobody on the Soviet side could see from their search grids was that metadata trumped mass. You could throw ships and aircraft at a rumor until fuel ran dry. Or you could let 4 ears give you a square that fit on a chart, and then send 1 submarine to do quiet work precisely. The United States chose the square. That choice became habit. Trust the faint line that crosses identically in 4 places more than the loud line that argues for attention. There was friction. Early on, one SOSUS report put a bearing a hair wrong thanks to a calibration drift. It would have widened the box in the worst direction. An operator with coffee breath and a pencil behind his ear caught the wobble by feel, not theory. Storm noise had a softness this line didn't. He made them rerun it. The bearings shifted back. Halibut's model later said that half degree mattered. Nobody got a medal. Someone wrote "check cal drift" on a whiteboard and underlined it twice. By the time Halibut sailed, the ghost map had layers. The acoustic fix, the current models, the towed sled's depth and field of view, the estimated debris arc if the hull broke on descent. That stack wasn't romance. It was insurance. Each layer ate uncertainty until a commander could say execute and believe it wasn't a coin flip. That's the metadata war's real prize, confidence without noise. And the payoff didn't end with 1 box. The discipline born in the K-129 hunt, the subtraction, the humility, The insistence on behavior over headline bled into everything IUSS did afterward. It taught the watchers that absence can be information when you know what ought to be present, and that a single good line drawn twice is worth 100 bad dots. The ocean was still chaos, but the Ghost had a map now, and the map fit. The Howard Hughes cover, Glomar shells, and the mining myth. While engineers sketched claws and pipe strings in windowless rooms, somebody had to answer a basic question. How do you sail a 619-foot ship to the middle of nowhere and sit on a grave without the Soviet Navy asking why? You don't. You invent a reason so big and so eccentric it sounds boring. Enter Howard Hughes. Hughes brought three things that made the lie work. First, a plausible obsession, manganese nodules, those potato-sized ore lumps scattered across abyssal plains. Second, a corporate labyrinth, some corporation at the top, Global Marine as the operational face, layers of contractors beneath. Third, a reputation for secrecy that read like camouflage. If anyone asked why the richest hermit on Earth wanted a prototype mining ship, his answer would be, because I can. The paper war started years before steel hit water. Contracts framed in industry jargon, feasibility studies with real math about nodule yields, and lease applications for seabed tracts turned fantasy into filings. Global Marine, already respected for deepwater drilling, took point. They talked riser technology and heave compensation without lying. A mining system and the CIA's lift looked uncomfortably similar. That was the point. If you saw a moon pool that opened like a garage door and pipes stacking 60 feet at a time, you'd think drilling rig, not spy crane. Summer handled burn rates engineered to make suspicion feel gauche. Between 1971 and 1974, the project burned roughly $800 million, about $4.9 billion today. It bought design teams, steel by the acre, the Sun 800 crane, and a floating barge with a secret, HMB-1. Built in Redwood City, California, HMB-1 was a submersible box with a retractable roof. Inside, Lockheed teams assembled the capture vehicle, Clementine, in total cover. In spring 1974, HMB-1 met the Glomar Explorer off Catalina. The barge sank, opened its roof. Glomar opened its moon pool. A claw the size of a building slid into a ship without anyone on shore seeing a thing. The cover story wasn't just logistics, it was theater. Press packets sold seafloor mining as the next big thing. Journalists toured selected spaces and wrote what they would show. Hughes's mystique did the rest. If he skipped cameras, that felt normal. If his spokesman went bland, that felt on brand. The ship's lines, boxy, crane-heavy, looked like function over form. No bristling antennas, no weapons, just an American oddity with research flags and marine science talk. OPSEC ran on economics. Crewing rosters mixed real mariners and CIA staff masked as global marine hires. Vendors shipped parts to shell locations. Invoices described mining systems, not intelligence tools. When a component needed a military-grade tolerance, a procurement clerk wrote prototype requirement and backed it with a spec sheet dense enough to end the conversation. Even failure modes rehearsed as mining hiccups. If a journalist asked about downtime, a Glomar flak could cite bearing issues in a novel riser application and sound honest. There was legal armor too, born of paranoia and good lawyering. Freedom of Information Act requests about the ship triggered a new phrase. We can neither confirm nor deny, the Glomar answered. It started as a response script to protect classified facts without lying. It became policy, then doctrine. The phrase outlived the ship, taught across agencies as a way to hold the line between curiosity and exposure. A leak didn't just threaten a mission, it threatened the habit of silence. Meanwhile, the Soviets had eyes, trawlers with antennas loitered. A research ship in a square nobody bothered with before drew attention, but the mining myth gave them a story they could sell upstairs. It fit biases, Americans as techno-capitalists chasing minerals under flags of convenience. When a Soviet officer radioed a report back home, he said what he saw, a platform laying and retrieving pipe through a central well. He didn't say claw, because he couldn't see it. The voyage choreography leaned into the eye. Deck drills staged as ore handling. The crew moved fabricated nodule bins, tested cranes, logged fake recovery cycles. Night ops masked real work. Aviation signatures looked like logistics flights. Signals discipline made noise look like commerce. Routine checks, weather traffic, maintenance calls that matched an industrial profile. Still, cover stories are brittle. In 1974, as Glomar worked the site, rumors traveled. Reporters smelled contradiction in mining economics, asked why a first-of-its-kind ship went to a patch with poor nodule density. The answer was volume. Test sites vary. Prototypes prove systems. It bought time. Inside Intel buildings, Glomar's success became a quiet referendum on statecraft. Build a functioning industry to hide a single objective. Spend real money as camouflage. Bury a hand under a laboratory of cranes and call it research. The risk felt surgical. If you pulled it off, you didn't just take steel off the bottom. You wrote a playbook. If you were Moscow and you couldn't prove the lie, you had to treat it as truth. That uncertainty cost fuel and budgets. Then the leak hit. On March 18, 1975, Jack Anderson broke the story. The Hughes mining ship was a CIA Trojan horse. The second phase, Project Matador, died on a byline. The Glomar answer went from form letter to cultural artifact. The cover had done its job exactly once, but once was enough to show a new kind of weapon, legitimacy engineered. You didn't have to outgun an adversary if you could out-imagine them and leave them arguing in a conference room about whether they'd been robbed. Clementine, the mechanical hand that shouldn't exist. Engineers hate the word impossible. They replace it with load paths and safety factors, then ask for thicker steel. Clementine started as that kind of refusal. On a drafting table, it was a rigid cage as long as a building is tall, with articulated jaws meant to wrap a broken hull 3 miles down and not let go. On paper, the loads were savage. A forward section of K-129 weighing hundreds of tons in water, then thousands once you start it moving, multiplied by heave and surge from a living ocean clawing at a 3-mile lever. They built her with a magic trick. Lockheed crews assembled Clementine inside HMB-1, a submersible barge with a roof that opened underwater. Redwood City workers called it a warehouse that dived. Inside, beams were marrying steel, ultra-high-strength alloy chosen because ordinary plate would yield before the first lift ticked 10 feet. The jaws were more than hooks. They were fingers on trunnions, driven by hydraulic rams on compliant mounts so the shock of contact wouldn't crack the frame. Everywhere, load spreaders, gussets, redundant pins. It looked overbuilt until you remembered the riser above it, a pipe string that would turn that mass into a violin string for the Pacific to pluck. Think of the rig like a vertical drilling system run backward. Riser pipes, 60-foot joints with tool joints the size of trash cans, stacked one by one through the moon pool, locked, pressure tested and lowered, the whole column guided by a heave compensator to cancel the ship's breathing. Build to 3 miles, and a simple problem turns cruel. Every joint adds weight and flex. The column wants to whip. The ship wants to roll. The hull wants to swing like a pendulum. They solved it with cadence. Lower on the trough, pause on the crest, and a passive active ballet. Pneumatic accumulators eating heave, drawworks paying out and picking up like a patient angler. At the bottom, Clementine needed eyes and touch. Cameras in pressurized housings peered through black water. Sonar painted the wreck as a ghost until floodlights made it real. The approach had to be millimeters honest because the Gulf's sail and fractured bow were traps. Clip the wrong edge and you shear metal that's waited 6 years to betray you. The test program rehearsed with steel mock-ups. They proved what theory hinted. Jaws must land clean, load must equalize fast, and any twist in the first seconds writes disaster into the next hour. Failure modes haunted checklists. Twist off at depth. The riser turning against a stuck capture vehicle got a whole section. Buckling in compression under dynamic load wrote another. Jaw fracture under asymmetric moment, an engineer's way of saying 1 finger bears the sin of 10, kept welders awake. So Clementine's beams got thicker at the knees. The jaw latches doubled. Strain gauges dotted the frame like freckles. Up top, the control room wore its paranoia openly. Analog meters for every joint tension, recorders scratching traces onto paper. crewmen watching needles like heart surgeons. Then came the hardest part, trusting steel against water. The Glomar's heave compensation had limits. If weather forced a stall mid-lift, the whole column hung in a grey zone, tension high enough to stretch steel, low enough to bang. Choices were ugly. Push and risk a snap. Hold and cook fatigue into every joint. They wrote procedures for weather windows and still learned in place. Sometimes you ride a sea you didn't forecast. Micro stories made it human. A pipe hand fought the torque of a 60-foot joint in the moon pool at 3 a.m., boots slick with spray, feeling the column hum a note you don't teach. A hydraulics tech bled a line on Clementine's elbow while the barge hatches sweated salt, whispering to a ram that would wake at 16,500 feet. A structure's lead rubbed a finger over a weld toe and didn't like the radius. He sent it back, earned a curse, saved a day. When Clementine finally kissed K-129, the physics turned slow. Jaws closed. Load crept onto the frame, then up the riser, then into the Glomar's bones. Steel side. The ship's Sun 800 crane took strain like a sentinel. A man in headphones called numbers calm as weather as the column rose inches, then feet. The plan had worked where plans go to die in the first inches, where slop turns into swing. For hours, the system ran as drawn. Pipe up. Break out. Stab. Do it again. The riser sang different notes as depth changed. A music the crew learned to fear and respect. And then the nightmare clause you can never delete. Fracture. Somewhere between bottom and daylight, grabber arms failed. A section of K-129 tore away and fell, a slow-motion death 3 miles long. The men on deck didn't see it. They felt it. A tension drop that shouldn't exist. A groan the whole system made when a promise broke. They kept the piece that stayed in the cage because that's what steel and humans do. Later, investigators would trace cracks and rerun films and argue whether it was material, geometry, or fate. On deck that day, Clementine had done the impossible and tasted the limit in the same breath. Here's the thing people miss. Calling it a claw understates it. Clementine was an ecosystem. Metallurgy, hydraulics, control theory, oceanography, and human nerve braided into a hand that could feel and lift through 3 miles of night. It shouldn't have existed. It did, long enough to bring a secret into daylight, and to prove that sometimes the difference between audacity and hubris, security lanes that holds one wave and a floating lie.